What? It's not fun. Oh, I had like 10 minutes to spare. I just got to decide if I want to play golf this weekend. If I want to actually no, if you can't, let me guess. Staying up late to do those chapters to get to the side.
No, that was morning. 2 a.m. I even started it, bro. I have this. I'm gonna do psych, lunch, English.
I came up with some fire.
My title is
Mine are so bad. Mine are so middle. I'm like yellow. Oh,
Okay, can you guys get started on this problem, please?
Are
we doing another worksheet today?
No, we're not getting a new worksheet today.
Good morning, everyone. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. One announcement, finishing on a high note, the Glenrock Middle School High School HSA is thrilled to announce that the HSA voted to donate $1,000 towards enhancements for the first floor teachers lounge. The space will be redesigned with input from our high school interior design teachers and students. Stay tuned for more information as the lounge transformation unfolds. Happy Friday.
What did you use on top? What did you use out of? I was going to make a
Your assignment from yesterday, everyone, you guys are just submitting it through Schoology. I'm not coming around and checking it. Okay, it's still, you have time. I think I made it until 11:59 p.m. today. So just submit it to me after, before the day is over, and you should be fine. Today, we forgot to do tangents, right? So we're doing graphs of tangents, and then we are taking sine, cosine, tangent graphs assessment next week. Like I said, the date is still tentative because you guys have AP exams and things like that. I want you to focus on that, okay?
Monday and Friday. Oh, wait, did you say check the following week? Wait,
Abigail, do you have chemistry on Friday? Like the test? Oh, I got you. Okay. No, I mean like Abigail, the test for chemistry, some kids are taking it on Friday though, right? Monday? Because I was thinking like if you had to take chemistry and bio on that day, that would have been rough. Yeah.
The last time that happened, it didn't end up well. Remember, everyone was not for them. Danny, did you get comments yet on your iPhone?
On my what?
The iPhone thing?
What do you think?
The English show we have to do over the week.
No, I didn't get mine yet. Did you?
Yeah.
She keeps saying she's going to,
Yeah,
and she keeps like finding more wedding pictures and getting. Oh god, this smoke. It's
No.
like. Yeah.
Is she slow doing it? Not real. I feel like she grades them. Very.
She grades it, she's done for the night.
I don't think about her. She's not here today. I dropped it. Speaking activity. Auditorium. How did you get your what time do you use it? I only went this first time yesterday. I have to get 7. I don't think I can do it. I will have that. Don't worry, I got the values. Yeah, it is. I'll grab it. Remember that your increment is starting with 5. That switching between is 5 or 6. Which means that you're going to make each of these 5 or 6. Oh, see that. That means that political division. Political division. Just divide, get the denominator. Denominator. Which reduce it down to 5 or 6. Should be 5 or 6. It's shitty.
Wait, they're going to 5 or 6?
Sorry?
What is it going to do?
2, 5 or 6, 3, 5 or 6, 5. Check it over. The whole no, shoot. It's supposed to be here. No, yeah, there you go. No. Increment. I'll be back. Thank you. Look at that.
Oh, that's something else.
I really.
Totally got that on my own.
That should not be a super guy. 5 or 6, 5 or 3, 5 or 3. Wait a minute. Every single increment you have is 5 or 6. So this means this is another 5 or 6, which is 2 5 or 6, 3 5 or 6, 4 5 or 6.
The bar is, I know, but we're probably gonna get like a crummy speaking activity. Doing the audit. Exactly. I grew up with it.
Yeah. Are you kidding?
I don't know, but you were sign up for.
Yeah, like write an essay. Oh, is this sign?
Oh, yeah. That is also good for the problem. So negative, that tells you that you have to that's not from middle. You don't have to do anything.
I do my. It's all.
Okay, so number 1 through 6. Let's take a look at this one. So our frequency value is going to be 3 now. So it's a little bit different from what we're used to. And even though like this number is not really quite something that we're used to, I'm not going to try to give you something that's super crazy. Like for example, like pi over 7, shifting it to the left. That's going to just mess up the whole, like the entire, increments and things like that. So I'm not going to give you something that's crazy as this. But what I am going to give you is make sure that whatever the horizontal transition is going to be, that it's kind of appropriate to the settings of your graph. Number 1 through 6, amplitude through vertical shift. Zach, can you tell me the answer for these? The frequency is just 3 and amplitude, they're all positive numbers, by the way. Yep.
New period is 2 pi over 3.
Perfect.
Each increment is 1 pi over 6.
Phase shift and vertical shift?
Phase shift to the left, pi over 2. And vertical shift is up.
Very good. So we have all the things that we need. Now, the first thing that we have to do is we got to make sure that our each increment, which is probably the most kind of confusing portion of this graph, is moving up by pi over 6 each time. So we have pi over 6, 2 pi over 6, 3 pi over 6, and then 4 pi over 6. And then you do the same thing on the other end. Now, if you would like to call these guys like reduced, like 2 over 3, 1 over 2, like pi over 2, pi over 3, be my guest. Well, like I said, for me, or at least for the purpose of this class, when I'm demonstrating for you, just to let you guys know how the increments work, you keep it consistently, like pi over 6, 2 pi over 6, you see that every single time you're moving up just by that much. And we are starting at, now we got to be careful about this. The phase shift is where we start from. Okay, so we're moving left pi over 2. So out of these values, because we're moving left, it's one of those 4 values going to be on this side. Zach, where are we going to start here? Which x value are we going to start? We're looking at pi over 2. That gives me pi over 2, right? So there we go. Oh, I think I forgot to do the framework here, so we got to do that. So positive 3, down at 0, down at positive 6 now, because the amplitude is also 3. And then we start at sine, which would make it middle at negative pi over 2. And then after that, you just kind of juggle back and forth. But you got to be careful. This is a negative sign, which means at the next coordinate, negative 2 pi over 6, do I go up or down, Zach? Down. And then just keep on juggling back and forth. So W shape, right? There we go. Okay, before we move on to tangent graphs for today, Abigail, you said you had questions on this stuff, right? How to do these? You can eliminate when it's sine and cosine, but you can't do it when it's. Oh, okay. Just take a look at the x, this value right here. It tells me it's 16 pi. And you know that one full cycle, okay, and you already know that this is a cosine wave based upon what you just said. So I'm going to eliminate all the answers with sine, okay? It's going to be either 3 cosine 4x or 3 cosine of 1/4x. I see that my period has been elongated to 16 pi. So which means it's a horizontal stretch. It's got to be 1/4. Or in other words, you take the original period and divide by the b value, you should get 8 pi for your one full cycle. This is one cycle right there. Okay, up until that halfway mark, that's one cycle, which happens at 8 pi because that's half of 16. So the only answer that the b value should work out for is 1/4. If it was answer for part B, let's say, then it's 2 pi over 4 for my new period, which is pi over 2. After every pi over 2, I should complete one cycle that looks like that. Okay? Yeah? Okay. Yeah, so just take a look at the x values, and that's all we got to do for that one. Let's see. Just for the sake of, kind of because we were on that relevant topic, write the equivalent trig equation of the following. This one, I'm going to also just leave it for you guys to do. Take a look at these two graphs. I'm going to zoom in as much as possible here. This, you can have various different types of answers, depending on how you see it. Okay, you can use cosine if you want to, or you can use sine if you want to. It's really up to you. If you really can't see where the midline is for the first one, I'm going to draw it for you guys here. Come up with a trig equation that actually describes this. That's the question here. Okay. I drew you those 5 points to indicate that that's how long it takes for these graphs to complete one cycle. If you're ever wondering how you can figure out a period from a graph, just pick 5 points up anywhere, okay? Like I picked from here, and then you go next 4 consecutive points and stop. That's how long it takes to complete one cycle. From here, you start from the origin or you start from the middle, and then you keep on alternating back and forth between those max and mid lines, and then you get one complete cycle. And these waves are not that complicated, especially for the first one. All you have to do is just one transformations. I hope you can see that. Dev, do you have the answer for me on this one?
I said negative cosine times pi, x minus pi.
Uh-huh. Plus, what is it?
Minus two.
-2. Okay. So negative cosine of x minus pi minus 2. Does anyone have a different answer for this one? Polina? Cosine x minus -2, because the midline is at 2. You see that? Like you go down 2. That's where your midline is. And then your amplitude. Yep, there you go. So
You do a sine.
you could do sine. What's your sine answer?
It would be negative sine x minus pi over 2.
Mm-hmm.
And then the minus 2.
-2. The consistent theme is that the -2 always has to be the midline, right? Guess what? All of these answers are actually correct. Because for Kevin's, we move right by pi over 2, which is right here. Okay, so that's your starting point, and then it's negative sign because I go down, and then you go like that. I actually have Polina's answer because it seems to me that all I got to do is just take a look at this and go, oh, I start at maximum, and these 5 points represents a regular cosine wave function. Amplitude is 1. All I got to do is then just shift it down by 2, and I'm done. Hence, 1 transformation is needed. Dev's answer is also correct. Dev decided to start at pi. So you move right by pi, but it's got to be negative cosine to indicate that this is a minimum. Yes, Sam? Yes. Because you're starting here, right? You're moving right by pi over 2, but then you start to go down afterwards, right? Yeah. That's the negative sine wave. So there we go. All of these answers, perfect, fantastic. Okay. For part F, Kevin, what's your answer?
Oh, I didn't get through.
Okay. Abigail, do you have it? No? Okay. If that's can I have a volunteer for this one? Yes, Zach?
I don't know if it's correct. Maybe negative sine 2x.
That's exactly what I have as well, right? So there are 2 transformations that I need for this one. I know that I start at the origin, so I can use sine wave. It looks to me like it just, I don't know. I just like to start at the y-axis and see what I'm dealing with. Okay, so I'm using sine, but I start to go downwards, which means I'm using negative sine. And also, if you take a look at the period, this one full cycle actually ends at pi. Remember, every full cycle happens at 2 pi for the original functions, like for this one. Okay, so I need to cut that by half, which means I have to divide by 2, like divide by the b value of the frequency. So therefore, there's going to be a 2 in there. So negative sine of 2x. Of course, if you decide to use cosine, you could do so. If you decide to use regular sine, you can do so. Yes, Jamie? Okay, yeah. So you see that one full wave happens at pi here, which means, you remember your new period is always 2 pi divided by b. You just set this equal to pi and just solve for b right there. Yes, Jeffrey? So cosine graph, you can do it positive cosine versus negative cosine. So let's say that I start here for regular cosine wave, right? Which means I have to use cosine. And we all know that the frequency has to be 2. X minus 3 pi over 4, because that's where I'm going to start. If I decide to use negative cosine, I can start to go from here, which is at minimum value. So negative cosine of 2, x minus pi over 4. Both of them will give me the exact same thing. Okay, and this too is because of the fact that it takes one full cycle happens in a pi span of time. Okay, not 2 pi span of time. So the frequency must always be 2, regardless of the situation, regardless of what type of trig function you decide to use. Okay. Any questions about this? Any further? Okay. All right. So today, I'm going to refresh your memory up a little bit. Okay. Do you guys remember what tangent graph looked like? Yes. Can you guys just like describe? Yeah. What was that? It was a bunch of like these waves, right? Okay. So we had these like sine waves and cosine waves that went like this, but then for tangent waves, it actually went like this. Okay, a bunch of like these little waves happening throughout the XY grid. So what I want to do today is, well, I went over with you that there's a special property for tangent that deals with sine and cosine. It's always sine of x over cosine of x, and that's how I showed you where those asymptote values were coming from. And tangents, they play by their own little rules, okay? At the end of today, you're going to be doing questions like that. Okay, yeah, I'm giving you the same graph transformation, except the only thing I'm changing is now it's tangent. And how is that gonna, what do I do in those type of situations? Okay, so we have to actually start from ground zero and then start from leveling off from the actual regular tangent waves. Okay, so if you don't have the regular tangent waves, let's do this first of all. Okay, we use the 5 values, the 5 essential points from the original sine, cosine, tangent, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I think I gave you a table, and this gotta be in your notes somewhere. If you look for it, it should be there. Okay. I drew this little table. And then I labeled these. And then tangent is nothing more than sine over cosine. So by using that property, I was able to find out what these values for tangent was going to be. Okay. Abigail, if you do sine over cosine, can you tell me the 5 values for tangent of x that I'm going to get here?
0, undefined, 0, undefined, 0.
That's right. 0, undefined, 0, undefined, 0. So tangent waves are nothing more than a bunch of zeros and undefines happening over and over and over again. But what's interesting about tangent is that the original period, you got to be paying close attention to this. So I'm going to sketch this for you real quick. I am going to label this still as pi over 2, pi, 3 pi over 2, and 2 pi, the good old days. And negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And then I start from the origin, which is 0. Then at pi over 2, I go to the undefined, which is an asymptote. 0, asymptote, 0, and then you just keep on repeating this process for every single one of these increments, right? And then there's nothing for you to do other than, okay, do I have to alternate back from max to minimum? No, nothing like that. You just plot the middle points, and then, you know, to the best of your knowledge, just, you know, try to draw the best way you can of these little, you know, cubic wave functions. Okay, that's where we left off last time. Okay, we only talked about regular tangent waves. So now for those of you who have the waves in front of you, now this is the question that we all must ask ourselves. What is the original period of the original parent function just regular tangent of x. Now remember, a period by definition means how long it takes for any periodic functions to complete one journey of cycle. Zach? It's not 2 pi. So a one full wave for tangent actually looks like this. It's this thing right here, because that's what's being repeated each time. You can see that, right? I can just click copy and paste it, and you will get the same thing over and over again. So that is how long it takes for you to complete one cycle. It seems to me that the starting point is somewhere around negative pi over 2, and end point is around pi over 2. It's pi. So that is actually what's different compared to other trig function, is that the original period for tangents is not 2 pi, it's pi. Okay, so that actually means, okay, so it kind of, it's making it a little bit more tricky compared to the other ones. But the good news is you don't have the alternating back and forth from max to minimum and all that good stuff, okay? All right, so now we took care of the regular tangent waves. Before I move on, are there any questions about this? Okay, that one original period are these little waves, okay? So it takes you pi radians to complete that. Okay. And you don't have to copy this next slide down, because we've already talked about this. I have never given you an amplitude of 20, because that would be a ridiculous graph. But let's say I gave you 20 tangent of x. Does anyone remember what I told you about the amplitude for tangent, Kevin?
Does it like stay the same?
Yeah, stay the same. You can completely ignore the amplitude, okay? The amplitude for tangent, it does not matter, because it just determines how, how quickly you rise up and then, from the left hand to right hand side. But given that the y scale is going to be really, really long, okay, you can actually make these two graphs look very, very similar to each other depending on how you set up your y-axis. If you notice something for tangent waves, I'm not really setting up for the y coordinates unless there is a need for it, such as vertical transitions, like moving up one or down one. However, the amplitude, you don't have to worry about that. And that's the good news about tangent. So you got one less thing to worry about. Okay, so for this slide, I'm not going to show it to you, but this wave, 220 tangent of x, you can draw it the same way as if you would draw a regular tangent of x. Okay, amplitude does not matter. That's what I need you to understand for tangent waves. All right, moving on to this. Last time when I gave you a homework, a lot of you guys were struggling with negative tangent of x, okay, because you kept on drawing it this way. That's not the shape that it's going to look like, okay? Can we all try this question? Because we should all know what that +2 does to the graph. And make sure that you have the each increment as the one that you just had before, the previous setting. But now try to graph negative tangent of x for me on that graph, please. And if you're done, if you have a graphing calculator, just please check your answers with whatever you sketched. And this is to verify that your wave should look more like that than the opposite wave. All right, so hopefully you guys have this, the same graph that you see on the board here. I have drawn you guys the midline. That's the only thing that I really worry about, okay? The regular tangent waves always happens in this opposite form. So if it's a negative tangent wave, just flip it over the midline, and you guys should all get this from left to right going downwards like this, okay? Again, your period is pretty much consistent. The only thing you have to worry about is moving up to, reflecting it over the midline. Okay. Hope you guys do not have any particular questions about these. And now the last part that I want to really talk to you about is how to deal with the period if I ever give it to you like this. I'm going to skip the horizontal transitions because I think you guys can all know what to do with that. But let's say I just mix them both. So only thing I really have to worry about is, okay, so we took care of amplitude, which means it doesn't matter. We took care, if I were to even put the +2 at the end, we all should know what to do with it. Now, the only problem is, probably the hardest portion of these guys is what to do when I get a period or the frequency value of 2, as well as the horizontal shift or phase shift, we like to call it, to left to right. The first thing that we always must take care of is this little guy over here. Jamie, what was our original period for a tangent again? Pi. So our frequency value here is 2, which means instead of saying original period, let's call it the new period. What will be our new period for this one? Using the same formula that we did for sine and cosine as well. So new period is always you take the original and divide by the b value. Pi over 2, yes. And I know that that's what you were going to say, yes, okay? Pi over 2. But since you guys had your hands up, Joshua, and if I have my new period as pi over 2, okay, that's all fine and dandy, but I really want to figure out what these guys are, right? What should I make each increment to be at then?
You divide that by 4.
That's right, always by 4. Guys, that still does not change. The only thing that really changed is this, that my original period was pi. So therefore, my new period is now pi over 2, even though my b value is, my frequency value is 2. Just plug it in. And then you divide that by 4, like you said. Josh, what would each of the increments be then? Pi over 8, okay? Pi over 8, 2 pi over 8, 3 pi over 8, and then 4 pi over 8. Then I'm going to go in the opposite direction and do the same thing. So now that takes care of your frequency and your new increments and all that good stuff. So that was pretty much the hardest portion about getting how to take care of the b value. Now I have this to deal with, minus pi over 2. Okay, and now the good news is my midline, it turns out that there's no vertical transitions whatsoever. So I think I can just make sure that my midpoints are always going to be on the x-axis. Sam, where do I begin? If it says minus pi over 2, x minus pi over 2, positive pi over 2, which means which increment should we start at? Very farthest one, because 4 pi over 8 is pi over 2, right? And then you're gonna start with always, guys, if you guys want to remember tangent graphs, they always start in middle. Okay, they always start in middle. And because for the original tangent functions, if you notice, we started at the origin. We start at the middle, and every other increment is just alternating back and forth. Okay, so this is still alternating because this is all periodic functions. Middle, and then asymptotes, middle, asymptotes, middle, asymptotes. And that's what we're going to do for this one. So here, that's the middle line. And then for the 3 pi over 8, I'm going to have my asymptote there. 2 pi over 8, I'm going to have a 0 value. And I'm going to have an asymptote here again. 0 at 0. Okay, because every pi over 8 increment, that's where these things are going to keep on alternating back and forth. This is how it's going to happen. So okay, I'm sorry. Something is not adding up here. Can you? Oh man, this is my fault. Yes.
I was gonna say, aren't the increments supposed to be pi over 4 instead of pi over 4?
Yes, that was my fault. I'm so sorry about that, guys. Can we just like kind of rewind back just a little bit? I made a terrible mistake on this one. So something was not adding up because my period was not gonna be pi over 2. Oof, boy. Okay, so let me just start over this. I'm very sorry, but we make the 4 increments and original period is pi over 2. The only thing that changes for tangent graphs, I've completely forgotten about this, is like Josh just said, we divided it by 4. For tangent waves, unfortunately, that is not going to be the case here, because if you take notice of the previous ones, okay? Yes, we took the entire period and then divided by 4, but our period only happened at pi, okay? We are not looking at 2 pi right here. We're looking at pi. And then with that pi here, we always just have to divide that into 2. So what I mean by that is for the new period each increment for the tangent graphs, I always want you to remember this. It's that new period, and then you have to divide that by 2. Instead of dividing it by 4 like what you did for the previous ones, you're always going to divide by 2. And that is what you're going to make each increment to be. I'm terribly sorry about getting that mixed up here. So like Sam said, we're going to make each of these as pi over 4s, and that should do the trick. 3 pi over 4, and then 4 pi over 4. The negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, and negative 4 pi over 4. And then each of these points will still, I think they will still be consistent. We move it to the right by pi over 2, which means it's 2 pi over 4. So that's where your middle line is going to be. But every other increment, which is the new period divided by 2, you make an asymptote, and then you draw a 0. Then you have an asymptote, 0, asymptote, 0. And then this span of time, regardless of which, you pick 2 asymptotes, and that span will always be the new period, which is pi over 2 for these guys. Okay, so now I think we should be in good shape now. Okay, so we have these asymptotes and zeros just keep on alternating back and forth. That's what's happening for tangent waves. And then the wave, you just draw it as it is. Okay, it's what you have seen before. There's no need for you to be super accurate with that. I'm not testing you to see how good of a drawer you are. I'm testing to see where the correct asymptotes and the zeros will be. That's the only thing I'm really looking for. Okay. Can we all just take our graphing calculators out real quick and then just sketch this? If you do not have one, I would like for you guys to use the computer, because yes. Yes, but then here, take a look at the original tangent functions. Your period was pi, wasn't it? But I didn't stop at pi. I stopped at double that amount. So it will always be that. So for tangent waves, that's something that's actually quite different. Because our original period is instead of it having happened at 2 pi, it's at pi. So you will see actually more full cycles compared to your sine and cosine waves. Like you have that's 3, and that makes it 4. So you see 4 cycles instead of seeing 2. Do you not? Okay. So what's consistent is that we have to end at pi because that's our original period, but we ended at 2 pi for our original graph, right? So in the similar manner, our original period is always at pi, but our new period makes it in such a way that I'm gonna see more cycles happens over time. So if my new period is pi over 2, which is 2 pi over 4, I'm gonna see on this last end value, your x, it will always be double that amount. Yeah. Jamie, technically speaking, like you don't have to draw it until here. I mean, if I just cut this part out, you know, that's, I mean, and then that's to the extent of what you will see if you just cut off at the 1 period mark, right? Yeah, so that's pretty much up to your window setting, basically. Okay. But for the sake of, you know, showing you this part, I'm just gonna leave it there. All right, so on your graphing calculator, could you guys all please type in tangent of 2x minus pi over 2? We're just gonna verify our graphs here. Tangent of 2 times x minus pi over 2, double parentheses after that. And for those of you that already know what to do next, go to Windows, and you're going to change your window settings exactly as what you see on your graph paper, what you just drew. The only suggestion is that the y min and y max, that's up to you to decide whatever you want to do. I just keep it as -10 to +10. So for x min, I have to change that to pi, negative pi, and this should be positive pi here. And for x scale, we made each increment to be pi over 2 divided by 2, so which is pi over 4. And y min and y max, I'll just keep it -10 and +10 like that. What is, okay. Okay, there we go. All right, and then if you press graph, there it is. Because each increment happens at pi over 4s, I can see exactly where the asymptotes would be and where the zeros would be. And it should be very similar to what you see on your graph paper, what you just sketched. All right, so let me give you a summary page of what we just talked about. There's 2 important things that I need you to remember. So amplitude, that's pretty much irrelevant at this case, okay? So this is a tangent full graph transformation for tangent equations. Your amplitude pretty much is negligible because it's irrelevant. Your frequency, this is your new period, not 2 pi over b, but pi over b. Phase shift, vertical shift, that's all good stuff. You know, it's pretty much consistent throughout the entire sine, cosine, tangent. But what you must also remember is this. I had it with me. I just don't know why I decided to divide by 4. My apologies from the previous ones. But new period divided by 2 should always be your each increment. Like I said, tangent plays by its own rules. They play in a different world compared to sine and cosine. So this is what I need you to remember. And I'm going to give you one last question. We have about less than 10 minutes, about 10 minutes left in the class, and then that's going to be it for today. For homework, I will give you guys maybe 2 or 3, just that's it, because I need you guys to study over the weekend for the other tests you'll have, which are much more important. Just tangent waves here. Okay, so in the beginning of the class, I told you that this is the type of question that I want you guys to do. So now we're going to incorporate everything and then see what happens. To give you a small hint for amplitude, you guys just can press, you guys can just put none in there, because that 5 really serves no purpose. But please, please, please pay attention to that negative. Okay, that changes the shape of the graph, please. And I know that some of you guys work much faster, so if you're done, you will have time to check with your graphing calculator. Please do so. Why that? What happened?
I forgot to do the plus one.
Oh. Yes.
It was the new
Uh-huh.
variable is, you said only like, there was one pi over two.
That's right.
Can you just draw up to pi over two instead of going?
Yes, you can do that. I just keep on drawing forwards because I have a habit of doing it.
Yeah.
But all I need to really see is at least 2 full cycles, and you're good. So yes, you can stop at pi over 2. You guys don't need to check, right? You guys already know you got it right? Okay. Yes, Danny? Oh. Yes. Moving it to the right side. Yes. So every other one is gonna be asymptote, and then it's gonna be a middle one. Then asymptote, then middle. You just keep on alternating back and forth. Then can you go to the left, and then so my next asymptote here would be at 0.
Oh, yeah.
And then 0 at here. That's right. Yes. And then you keep on alternating.
Good job.
That is excellent. Great job. Well done. Moving it right back up. I guess you just kind of did not add the plus 1.
Oh, I have it tens, like.
Oh, it's kind of hard.
Yeah, I guess. I like working two or something.
Okay. Well done. Well done. Great.
Yeah, Mr. Kim, when I made it smaller,
It worked out that way. Okay, great.
Is that it for the day, Mr. Kim?
What's up?
Is that it?
That's for the day, but let me just go over this real quick first, and then we'll just. pi over. Wait, Danny, that's the only thing you didn't account for, right?
Yeah.
So everything else is good then.
Yeah.
Great. Okay, so since you guys already know the graph transformations, you guys should catch on to this real quick. In some ways, tangent waves are a lot easier because all you got to do is just draw a bunch of waves. Each increment, the new period should be pi over 2, so therefore it should be pi over 4. Remember, now it's each increment is divided by 2 from your new period. So pi over 2, this is 3 pi over 4, and this is pi. So you guys should have the same thing here. And like I said, if I ever give you an assessment on these things, even if it doesn't matches up like with the well, actually the translation left to right, whatever it is, if it doesn't match up with the grid, I will make sure that it's at least like halfway between or 1/3 way between. I am not going to give you something crazy like I said, like pi over 7. Okay, that is not going to happen. But anyways, after this, we just have to take a look at where we begin. Remember, tangent waves always start at the middle. And then pi over 4 is where we're going to start at the middle line here. And then you just draw a bunch of asymptotes afterwards. Zeros, asymptotes. Asymptotes 0, asymptotes 0. This is negative tangent. So I'm expecting to see a bunch of waves that looks like that. Okay. Thank you very much. Have a great weekend, everybody. Yes.
When I do this in the calculator, it just draws vertical line basically.
That's because your y setting is based very, very low. Your y is just 1. So you're not going to see a little bit of a curve there. So you might want to increase this just a little bit, and then you will see much more.
Because yeah, I had it at 4 and -4. So I
Oh, you
thought
kind of
maybe to move it to 1.
Then it's more straight.
Then I would think if it's smaller, then you just see the middle part.
No, you have to expand it. You have to expand it a lot more. Are you giving your calculator back? The homework? Well, submission is due by the end of today. So everything is Schoology. I'm not checking it in person. Yes, everyone online. So if you actually increase this, you see more wave here. Let me show you. See, like you see way more.
Yeah, I think it would be the opposite because if you were to make this smaller,
but
5 and -5, then you would only see the middle. So it would be
right. But then if you imagine you just zooming into that portion, you will just see a straight line there. Yeah, because you're not going to be able to see these curves. Like it's like you have a grand map, right? Map of the world, and you're only seeing like one small teeny city. Like so, you can't see how the world is shaped just by looking at that one part area. I guess that's the best way to explain it to you. Yeah, there you go.
thanks.
Mr.
Yep,
Kim,
yep.
you know that problem that like we had to redo
Which one?
during class
See
today
ya.
where the increments were incorrect at
Yeah,
first?
yeah.
Can I take a photo of that? Because I do my notes in pen and now I'll redo it at
Oh,
home.
yeah. So you want me to go back to this
Yeah,
notes?
'cause I just gotta redo it later.
But it's basically this one right here. That all new period should be divided by 2 is instead. That's all you got to do.
Oh, so the first one we did was
With the pi of like I made a mistake and divided this by 4. Remember that? That I cannot do for the new period for each.
Oh yeah, no, I understand what you did. I just got a copy down later.
Oh, so you just want to take a picture of
Yeah,
this?
because I just got a copy. I did my notes in pen, so I can't really read.
All right, there you go. Yes.
What's up? I think I messed something up on Windows. And I have
Okay.
no idea what I did.
So first of all, your Windows setting here, Ymin, Ymax. Yeah, your Xmax is really big.
That was pi before, and I'm still getting. I think because Sam changed this number.
You mean this number?
Yeah,
Okay.
and yeah, and it still gave me an error.
Ah, okay. So then you know what? This is what we're gonna do. So when in doubt, just press zoom and then press 6 for me.
6.
Yep. Zoom standard. Okay, so it still doesn't do anything because this value has changed. Do you mind if I reset memory here?
Yeah, sure.
I think I might have to do that. Reset all RAM. Okay. So now I'm gonna just type it for you real quick. Tangent up to. Thank you. Have a good day. Pi. What was it? Pi over 2, right?
Yeah.
And then plus 1. Window negative pi. Then this is pi over 4.
Oh, there we go.
There we go. Yep. Just reset the setting.
Thank you.
Yep. No problem.